Question 9 asks you to do a current voltage graph for a filament lamp. And I was about to jump straight in and to draw the sort of graphs we've drawn in class before. And so I'll just notice it does actually say a current voltage graph. Now normally we do voltage current graph, because a voltage against current graph has voltage on the y-axis and current on the x-axis. But a current against voltage graph would have current on the y-axis and voltage on the x-axis. So it is a little bit of a trick that they've thrown in there. Can't think why they've thrown it in, apart from trying to trick you. Now it does say to sketch a graph, and it says sketch on graph paper. Well, if this was an exam, there probably would be some graph paper printed there amongst the question for you. And it's worth thinking what we mean by sketch. If you're told to sketch a graph, it means you don't have to plot all the points as you would if you're plotting a graph in an experiment. So sketching is easier than plotting all the points, but sketch doesn't just mean do it any old how freehand. If they've given you numbers in the question, when you sketch a graph, you're supposed to sort of show that the graph you have drawn relates to those numbers that were given. So it says I've got to draw the graph for positive voltages up to 12 volts and for currents up to 3 amps. So I need to decide on the scale, and obviously in a real exam I need to look at how big the graph paper was that was provided. The question is expecting us to do some calculations, and it tells us we've got to show them. So what do we know? We know that the resistance is constant, and a constant value of 1.5 ohm for currents between 0 and 0.5 amps. And we know that if the resistance is constant, we'd expect the graph of current against voltage to be a straight line for that part. So we start with a straight line that represents a resistance of 1.5 ohms. So how do we draw that line? Well, if we use the equation P equals I times R, we can work out what voltage do we plot for a current of 0.5 amps. So it's 0.5 amps times 1.5 ohms, 0.75 volts. So our graph has got to pass through the point that's got a current of 0.5 amps and a voltage of 0.75 volts. It also passes through 0, 0, and once we've gone past 0.5 amps, it's no longer a straight line, but it's got to reach this point 12 volts, 3 amps. So before we can plot the graph, we need a set of axes. Here's one I prepared earlier. This graph wouldn't be big enough if you were doing a graph in an ISA, if you're actually doing a practical experiment, but if this was an exam question, the chances are the graph would be this sort of size, and they probably provided some graph paper as part of the question. So we know that the graph goes through 0, 0. We know we've got a straight line until the current is 0.5 amps and the voltage is 0.75 volts. We've got 5 small squares representing 1 volt, so each small square represents 0.2 volt, 0.75 should be there. So the graph is a straight line up to there, and then the only other point we know is that when the voltage is 12 volts, we know that the current is 3 amps. So we can use a ruler for the first part. Straight line there, and then the graph curves to finish up at that point. So we do our best shot of a nice smooth curve coming round to that point. So there we are. Part B asks you to do a current voltage characteristic for a semiconductor diode. Interestingly, with diodes we generally do them current voltage, so maybe that's why the first part asks for current voltage as well. I'm not going to show you how to do that one because you can look that up. But you do have to make sure that you do show the behaviour for negative voltages as well as for positive ones.